What?
Number E on the first worksheet we were just on.
Did we not do it?
No, it's just.
Yes, we did.
We did?
Yeah, there was two values.
No. I guess we did. I just combined them on my worksheet, I'm sorry.
That's fine.
Later.
That's fine. Yeah, let's do the first one.
Are we gonna have to answer all these questions?
Well, if you look at some of those questions, they're like draw a scatter plot. Hardly a question. Find the exponential function that fits it is the standard procedure. So right away, those are two gone. Express the function. Yeah, you're going to have to write me. This is going to be what your answers will look like. When I say, what's your model? This is your answer.
Do we have to do it in the, whatever it has to be?
What do you mean by that?
It says, in the form,
No, whatever form the calculator gives you is fine. I'm just grabbing this page because it has data on it. That behaves pretty good. Okay. Yeah, let's go ahead and do the first one. I may have to put a little disclaimer on here. Clearly, from reading through the paper, you see this is exponential, right? This is from an exponential out of another book of yours. The data for this exponential may look like exponential or may not. I'm going to make sure that the data that you guys have on your quiz is going to be clearly one of the types from our knowledge of what we've studied in class, from cubics to quadratics to exponential, or possibly even a straight line, right? I think this data will look linear. So let's see what it does. So we'll start out, same process. I'll go a little bit faster now since you guys are all good at it. We're going to go down to clear list. Clear list 1, clear list 2. And we'll go to the editor. Let's go ahead and start putting in the data. This is number 1, starts with a 0.
you said just linear quadratic.
Let me answer that 1 second. Let's get this data in. I'm going to take a second to check this side. I got 188.3, 75.9, 69.4, 8, 45. Okay. Do yourself a favor and check the entries, okay? One value different, and your answer will be, and possibly significantly be, different than what the answer is on the test and get marked wrong. Just because you put in an 85 instead of an 88. The first person to admit I punch wrong numbers in everything all the time. So because of that, I make sure that I go back and double check. It's not a bad thing, and how long does it take? It's worth it. So just do yourself a favor, go back over the data, make sure you've got the numbers in right, just so you can be done with that. Now, remember to go clear out Y1. We don't want to look at any old work here. Run this. Sorry, not going to run anything yet. I'm going to hit zoom stat. Yeah, that's what I thought. Go ahead and run zoom stat and get that picture. Did you guys get that yet? Still working on you guys there. Everybody got this picture? Hope you do. Okay. Looking at that, I would almost say to you guys, yeah, that kind of looks linear, doesn't it? I could see a line going through that. It does kind of have a nice little curve to it too, if you look at it, but a line is not completely out of the question here. I'm going to run an exponential decay through this thing. because well, that's the section we're in, and it will actually fit better. We'll actually do both, to show you. The data that you see on the test, we're not really at the level yet where we can make some judgments about this stuff. So it will be more on the lines of this. Okay. If you see this one right here, this is clearly not a line, right? And it kind of almost looks like a parabola, but it has no other side over here, does it? So we're going to call this, the exponential function will do both decay and growth. So we're going to run it, well, let's first do the linear regression just to see. So what we want to do is go to stats, calculate linear regression. We did this last Tuesday.
Do you have to both lines at the same time?
No. Well, yes, but not, we have to calculate it separately and then graph it.
But if you've already done like
Yes, put it into Y2, or whatever you're doing next. I'm doing linear first. See my linear regression here? And I'm going to put that into my Y1 variable. And I want to look at the graph. And there goes a line right through the data. And you know what? That's not half bad, is it? I could not argue with any one of you here if you said it looks linear. It does look linear. It's going to turn out that the exponential decay is going to be better. But that's only because this thing is, well, it's modeled after an exponential decay. The ones that you will see will be clearly exponential decay. We could spend an entire semester talking about what models to use for what stat problem. There is a class called elementary statistics and regression that you will learn how to do this in. But for now, we're going to say if you put this line through here on the test, I could not mark this wrong. Let's just go ahead though and run a second regression under stats. I'm going to go down to exponential. Exponential regression, or XREG. We'll do both exponential growth or decay. It doesn't matter. It will change the numbers accordingly. So let's run this one. And of course, I've already got it in Y1, so I want to put this one, say, in Y2, right? So go down to Y2 this time. So you have this command, and we'll run this one. Now, when I graph this thing, it will first do the line, and then it will do the exponential decay. You tell me which one's better. There's the line. Now look at the decay. Decay gets every point. If you were modeling this data and wanted a function to represent this behavior, which one would you say is better? The second one, clearly, right? But I couldn't mark you wrong for linear on this one because you guys are just learning this, and we're basically, that looks linear as well. So, I know I'm repeating myself over and over again, but you will know clearly which one to use on the test. I will make sure of it, because I'm not going to put data on here that looks linear. If it does look linear, use linear. If it looks like quadratic, use quadratic. If it looks cubic, use cubic. Or if it exhibits any behavior like this, or perhaps the other version, which looks like something like this. This is exponential growth, right? They start out growing kind of fast and then really take off. Then you would use the same regression, EXP-REG, and it will give you the right answer.
when you hit exponential regression, what did you put in?
It's all the way down. You go down till you find EXP-REG.
Zero. It's zero, but then what do you do?
Put it in Y2. So
In
hit
Y2?
bars.
Oh, yeah, sorry.
Bar stands for variables, by the way. But it looks like bars, is what I say. All right.
And then just the graph?
Did you put it in Y2?
Yeah.
Did you run it?
Yeah.
Hit enter so that it is, and then did graph it. Any question I want to answer is readily available here. Let's see, coming down. Oh, for E, this is a good question. Of course, if I ask you for half-life, I've already told you what regression to use by default, right? Because what's the only thing that has half-lives? Exponential. Okay, so probably won't use that kind of wording. If I do and you don't use, well, whatever. We're not gonna go there. So it says, find the half-life. How much did we start with this stuff, according to the problem? 100 grams. So half-life would be 50 grams. So you would go to Y2,